Hello everybody, my name is Pixel Rain, or Rain for short, and today we're going to be adding water and terrain manipulation to our Voxel engine, I guess you could call it. To get started, we're going to go ahead and open up our Voxel struct, and we'll be adding two new values to it. This will not be what it looks like permanently. I will be replacing this with bit shifting in the next video, but for the sake of time, we're just gonna use this float active value and integer for can't update further. The active value will represent the, well, active value for an active block like water, so it'll be the amount it can still spread. And can't update further is just to make sure we aren't running it when unnecessary. Now we're going to head over to our compute manager, and we're going to be making our mesh buffer counter a 3-part, and also removing the count value because it's not used. The third part of the mesh buffer will be for transparent indexes, and the point of having those would be so that we can have transparent blocks, because you can't have transparency in the same shader as non-transparent mesh. I tried, it doesn't work. I got a mess in my copied code, but noise buffer down in noise buffer is going up to a stride of 12 because Voxel now has 3 4-byte variables in it. And then we get down into our mesh buffer here, and we're going to add our transparent index buffer to it. We'll be setting our count buffer to that size of 3 and setting our data to 0 across the array. Our max tries, we're going to actually increase the total amount of max tries we can have, because if you put water in a high place, it will spread and you'll quickly run out of tries available within that little area. Can't copy and paste today apparently. Then we're going to replace our modified noise buffers stride to 12 as well to match our voxels, and we'll initialize our transparent index buffer. Then we just need to dispose of our transparent index buffer, and we'll be moving on to compute shaders. The first thing we need to do is update our voxel struct here. And then we'll be adding our index buffer. And then we're going to add a new function that works like voxel is solid, except we're checking if the voxel ID is 240 because that is the random byte value I chose to assign to water. It's high enough that nothing should really interfere with it, and it's still within the appropriate range for a byte value. Then in our calculate contour, we're going to be adding a new integer for the root cell ID and the adjacent cell ID so that we can do some weird swapping to trick ground into thinking that water is air and water into thinking that ground is air, so that we can get away with making it contour to each other properly. It's weird because you don't want the water and the dirt to actually interact. You want them to be two separate things. If they interact and you have flowing water, then you can see the terrain underneath changing, and that is definitely not the behavior that we want. So it's easier just to make it think it's air. And we're just updating our adjacent cell ID and adjacent root cell to actually be the new integers we've placed in here. Same thing that I did up here when I copied and pasted it in. And then we're going to make our poor color float even longer. All we're doing here is adding a check for if the block ID is 240. If it is, then we'll set the color to 240 flat, because our water will be shaded only by color, not by texture. Otherwise, we'll continue our checks of use texture and so on and so forth. Then we'll be adding a new check on our voxel face. So we'll be going from just checking if the adjacent voxel is solid to making sure it's solid and not transparent. then we want to continue. Or if we're a water block and the opposing block is transparent, then we want to continue as well. Basically, we want to make sure that the face is drawn against water if it's ground, and vice versa, so that you don't have holes where water and ground meet. Then we're going to add a slightly different add for our triangle counters. We'll be incrementing counter 1 with our standard try count and counter 2 as our transparent tries. And then we'll place our triangles in the array following that count buffer. And same thing down here for the shared vertice implementation. Okay, that's all sorted out. So now we'll go over to our height map noise, and all we're doing over here is fixing our voxel because it now has 2 values that aren't filled everywhere. So then we'll come down here, place that in there. And also, if our Y position that we're checking is greater than terrain height, but if our Y position is less than 2, we'll make it into water for right now, because the way the noise generation works, you get those weird looking, you get those almost riverbed looking aspects of the terrain, so we can take advantage of that and just fill it with water. It's kind of cheating, I'm not gonna lie, but it makes it look prettier. And then we'll add our voxel values in here so that the struct is considered complete by the shader. And we'll move on to our world manager. So one of the first things we're changing here is we're changing our world material to world materials so that we can have our transparent shader as well as our standard shader. We'll be adding a new dictionary of type concurrent and recursively concurrent, just to mess with you, of active voxels, and this will house any blocks that are updated frame by frame. We'll also be making a new thread called check active voxels and updating our world material to update the 0th entry in our world materials array to set the texture array for it. And then we're going to kick off our active voxels thread. And then we are also going to make a change to our chunk state right around here, just to make sure that we're keeping our state where it's supposed to be. Then for our actual loop that we're going to be using for our check active voxels, this is what it's going to look like. So we'll iterate over all the key value pairs in our active voxels, which we can then check against active chunks to make sure we're not trying to update active voxels in a chunk that is not being rendered currently. If it is, we'll go ahead and verify that we haven't already told that chunk it needs to process the block tick. If we haven't, then we'll check the active voxels that are in that dictionary's value, and that'll just be the position of the active block as well as the voxel value of it. If that value is less than 0.15, then we'll go ahead and remove it from that dictionary so that we aren't checking it every frame. That'll be the same as checking if it needs updated being set to false. And then we will add it to the chunks block positions to update. If it's greater than 0, so if we actually hit something in here that works, we want to go ahead and tell it it needs to be remeshed. And then we'll be changing our chunk initialize down here to world materials. And when we shut down, we want to make sure that our check active voxels thread is being aborted, just so it's not running in the background. Moseying on down to our already very large indexing into various chunks and chunk borders. We'll be adding a boolean to check if our voxel is 240 or water. And then if it is, then we're going to modify the way that we're doing our modified voxels here. So if it's active, then we'll be adding it to the active voxels as opposed to modified voxels. If not, we'll do it the old way and add it to modified voxels. Same thing for if we're placing it within our local chunk. If it's active, blah, blah, blah. And that'll wrap it up for our world manager changes. Only errors we have right now are chunk changes that we're going to make right now, so no worries here. The first thing we'll be doing here is not making that a double space. We'll be adding a boolean for need process block ticks and a list of vector 3s for block positions that we need to check and update. Our initialize will become material array and mats, and then we'll pass that off into our mesh renderer. I think it's just share materials, right? Yep. And then we'll go on down to our where is it? We'll go on down to our process noise for structs method, and we'll be adding another little section here that we actually process our blocks in. So if we need to process them, we'll iterate over the list. Then we'll call our active voxel manager update voxel function with our chunk position voxel, or I'm sorry, chunk position, the position of the block, and then the reference to the world manager's active voxel dictionary. We'll be making active voxel manager here in a second. And we do this after we place our foliage so that we can actually make water react to the foliage, because if we do it before, then if you place a block against the tree, it'll just kind of float through it, and that's definitely not the behavior we're looking for. And then down here, we're going to go to upload mesh, make face count a array of 3. We'll be copying our transparent indices off of face count 2, and then we will be changing, and then we'll be getting our transparent index buffer into our transparent indices array. Again, going off that face count 2. We want to set our mesh submesh count to 2 so that we can have a opaque mesh and a transparent mesh in the same mesh overall. And we will no longer be using set indices, but we will be using set triangles instead, because it plays nicer with 2 meshes, or 2 submeshes, excuse me. And then we'll move down to our mesh data, where we're going to add our transparent indices array, and we'll also set that to null when we call clear arrays. There is absolutely no reason to have this initialize here, so I'm going to pull that out, which I believe will cause an error in World Manager that we'll go fix up real quick. Just take that out of there. I say it doesn't matter because we should be making the arrays here, so there's no reason to pre-initialize it at startup. All right, now we'll move on to making our active voxel manager. Active voxel manager. And on the classes that I'm making here, because I will be making one more after this, I will be skimming over it so it doesn't take too long. So update voxel will call the respective function for whatever active voxel it is. Right now we only have water, and that's sitting at block ID 240. So we'll call update water, passing in the arguments from update voxel. And this is, like I said, or like I've said a couple times, a fairly simple water movement function. It's nothing complex at all. So what we do first is we check if there's a block below the position that we're at. If there's not, Then we'll set our can't update further to 1 and set the block below this one to water as well. So it'll propagate downward regardless of the active value, assuming it's not already passed below our active value threshold here. So you can see that here we set the can't update further, we set the voxel at that coordinate, which will update the active voxels, and then we do the same thing for the position below it, except we give it an active value of 1 and set can't update further to 0, so we know that we can propagate that water out. And then when we actually hit ground here, so if our down position doesn't equal 0, then we'll just expand the water in a -1 to 1 range on the X and Z axis. It's a little wonky here because it has a hard time checking voxel values across chunk bounds, but it seems to work pretty well so far. So yeah, that's pretty much all this does, is just iterate through -1 to 1 on X and Z and set the block value accordingly. It also reduces the active value of the block we're currently on by -0.15. And at the end of this loop, we set our voxel value to can't update further because we've already propagated it as far as it's going to go in this loop. Now we'll be making another script. This one will actually be for our camera, and this is our terrain manipulation tool. So this will be called Terrain Interactor. And like Active Voxel Manager, we'll just quickly go over the script. So it's got a couple options for how it works. You'll have a replace block in place that will replace whatever block is hit with the raycast. Otherwise, it'll put it outside of it. So if you're facing forward, it'll put it one block closer to you than the one you're looking at. There is two different tool modes, continuous and single, where continuous means if you hold down your right click, it'll continue to place or modify blocks. And tool type is single or radius, so that means you'll either be placing or removing or changing a single block, or it'll place a cube essentially at the location of your raycast. Radius to effect has to do directly with the radius tool type, and voxel ID to place is just what voxel ID you want to place. You can set it to 0 to destroy terrain, or you can leave it at whatever terrain value you want to manipulate everything. We've got some basic key codes in here, so if you hit space, it'll toggle replace block. If you hit tab, it'll switch your tool mode from single to continuous and back. If you hit M, this is a little function that I was using in the demo videos. It'll switch it to continuous and affecting single block only, not in a radius, and place water. So you can place water throughout your map. And then we've got our actual, if our tool mode is single and we've got mouse down, or if it's continuous and we've got it just held down, we'll go ahead and get the block coordinate at the ray. And we do some checks here to make sure that we're not trying to place a block underneath our world. We've got our active value here. So if we're placing water, we want that to be set to 1. And then we pretty much just set the voxels at the correct coordinates. If you're not using single block, it will just iterate over a radius according to radius to effect. Nothing particularly fancy here. And then our actual get block coord at ray is a little bit of a hodgepodge of raycast position checks. It's not 100% accurate when you're working with contoured terrain. This was set up originally for use in my voxel model maker. And you would do your editing with cubes, and then you would let it turn back into contoured mesh after the fact. So I'll leave you to go over this, much like the indexing in World Manager. It's probably not the best approach to it, but it works. And if someone's got some suggestions for it, they can always go to my GitHub and put in a pull request on it. I will probably merge it through. So that does it for our scripting today. The only other thing we'll be doing, and I won't be showing you the making of this shader because it is a water shader and it takes, and they have actual videos on water shaders, so, but what you'll do is you'll make a new voxel shader transparent. On the graph settings, you'll have your surface set to transparent with blend off of alpha, and then you'll take your vertex color, split it, and much like your previous shaders, you'll pass your G into unpack floats to get our smoothness and metallic values. Your B and A is still UVs. So as you can see here, I've got the UVs going into a radial shear, which goes into Voronoi noise, which is fed off of time with some variables for ripple speed and ripple scale. Let me zoom in a little bit, make it a little bit easier to see here. So yeah, we've got ripple speed times time going into the angle offset of Voronoi with the ripple scale going into the cell density. And then we take the power of that times our ripple slimness and we multiply that by our ripple color. And then we pass that into our float to color, which is pretty much just going to check if we're looking at water. And if we are, then we'll take our output from our ripples up here and we'll pass that as our actual color going into our base color. And then we'll also take the alpha from our watercolor and pass that out to the alpha of the fragment shader. If it's not water, it's going to be white right now if it's coming through this shader because water is the only thing we have supported. As always, you can find the latest source on my GitHub, so if you have any issues making this work, feel free to go there, or you can always come over to my Discord channel and ask me directly why I skipped over so much in the tutorial. So then we'll go ahead and make a new transparent world material. Set that to our voxel shader transparent. These are the defaults in case you are wondering. Give myself a little bit of alpha on that. Probably about there. So we've got a ripple speed of 1, a ripple scale of 7, and a slimness of 5. I'm not 100% sure if that's accurate or not, but we'll see. Then we'll come back to our world manager and assign our world material and world material transparent materials into it. This is the defaults for the water, so you can see where my alpha is. We'll bring that down just a little bit. We've got a ripple speed of 1, a ripple scale of 15, and a ripple slimness of, let's just call that 14. And then we want to go ahead and assign our terrain interactor to our camera. Set the tool mode to continuous. We'll set it to a radius of, let's say 4, and voxel ID to place to 0. So that should mean when we right click, it destroys the terrain. And look at that. The water seems to be placing itself properly. And it looks like you can kind of see through it in some of these places. Let's take a look. Okay, it's not super transparent, so let's go over to our world material transparent and lower that alpha down to 80. And there we go. Now you can see through it. And as you can see, the water is flat. Probably a little too transparent, but you can feel free to mess with the settings on that shader as you wish. And then we'll just come over here to my favorite mountain to destroy. And if we right click, you can see we start taking chunks out of it. I'm sure you also notice the little holes that appear sometimes. There's clearly an issue somewhere with the voxel placement on chunk borders. I will probably be fixing that in the next video because I don't have any other plans yet for part 9. But it's not bad. It's pretty quick. And then if you hit M and hold down your right click, you can also place water. You can see it flowing. And let's see. We can also, if I go to the right component here, change our voxel ID to place to, let's just do 1. And you can grow terrain. Now, I do promise this is slightly faster than this normally, but I'm also recording a video right now, so that's not doing super well for my computer, but there you have it. We've got terrain manipulation, active water, non-active water, and that'll be it for this video. So if you like the video, don't forget to like and subscribe. I know everybody hates hearing it, but I'm a small channel and it does help me out. If you need help with anything or you just want to come hang out, there's a link to my Discord channel in the video description. And if you really like the series so far, feel free to go on over to my Patreon. That's also in the video description. There's a few perks in there for you if you want to check that out. And that's all I've got for you guys today, so I will see you in the next video.